Okay, I'm
All right.
sorry, Jesus.
So, here we go. Like I said, guys, nothing new today. Nothing new today. It's just we practicing more of the stuff we did yesterday. So, the first two problems. Cotangent theta equals 1, tangent theta equals negative square root of 3 over 3. Cotangent and tangent, when we work backwards, are a lot tougher than the other four. Because we're doing we have to find two different values, x and y. Right? If cotangent equals 1, or cotangent equals negative 1, it's really easy, because it's the same number, right? If it equals a weird number like tangent does right now, it's going to make it a lot more complicated, and we'll talk about that in about 5 seconds. Alright? So, cotangent theta equals 1. Well, cotangent theta is x divided by y equals 1. What two numbers, when divided by, when we do division, equal 1? The same numbers, right? 3 divided by 3, 5 divided by 5, negative 6 divided by negative 6. So I know if I'm going to divide x and y, and it equals 1, that x has to equal y. So on my unit circle, I need to go up here, and I need to find where is x equal to y. Well, right here it is. Right here it is. And those are the only two spots. So at 225 degrees and at 45 degrees. And those are my two answers. So 45 degrees, which is also pi over 4, and 225, which is 5 pi over 4. Those are the easy ones, when cotangent or tangent equals 1 or negative 1. Those ones are nice and easy. Right? The next one is a bear. Right? It's terrible. It's a lot of work. It's really tough. It's tough for people to grasp, and there's really not a good way to teach it.
So it's not a good problem.
It's not my favorite problem, put it that way.
Is it on?
Working backwards will be on the test.
But will the ugly one?
Working backwards will be on the
That
test.
means it's going to be on.
I'm not going to tell you what problems will or will not be on the test. Alright? I will tell you working backwards will be on the test. Any working backwards problems will be on the back side of the test. Alright? So, let's look at this. Tangent theta equals negative square root of 3 over 3. Is there anywhere in a unit circle that I can get a positive 3? Any x or y value? Is there any way I can get a 3 out of there?
The 1/2.
But there's no 3, is there? There's 1/2, there's square root of 2, there's 2, there's square root of 3, there's 2. There's no 3. Which means what must have happened? I must have rationalized it before, right? I had to have done square root of 3 times square root of 3 to get positive 3. Which means before I'm going to try and solve this like this, I'm going to change it back to what it was before it was rationalized. Well, there's an easy way to do that. Just multiply top and bottom by square root of 3. So, what I'm going to do, times square root of 3 over square root of 3. So I get negative 3 over 3 square roots of 3 on top, or on bottom, excuse me. And I need to simplify that. My 3's cancel, and I get negative 1 over square root of 3. Right? We all follow that part.
Yeah.
Alright. Tangent theta, in terms of x and y, is what? On our unit circle, tangent theta is equal to y over x, or y divided by x. And I know that needs to equal negative 1 over square root of 3. Alright. When we do this, whenever we do y divided by x, what do we always end up doing? We always end up multiplying by the reciprocal, right? Or changing it. That means we always take x, or the second term, and we always flip it. Now, we need to figure out, one of these two terms is going to have a square root of 3 in it. Right? We got to figure out which one it's going to be. If it's y, does my square root of 3 ever get to the denominator? No, it stays the same, right? We do keep, change, flip. So if y was to equal square root of 3 over 2, my square root of 3 would always stay in the numerator. Is that what I want? No, right? I want to get my square root of 3 into the denominator. So my x is going to have a square root of 3 in its numerator. Does that make sense?
Yes.
No. I heard no's. Alright, so if I have any number, say I said y was equal to square root of 3. You don't need to write this down, it's not correct. If I said y was equal to square root of 3 over 2, and I picked any number for x, set up, let's say 1 over 2. Right, I said x is equal to 2. If I do keep, change, flip, do I get my square root of 3 to go into the denominator?
Oh, no.
No. Would that benefit me at all then? No, because I want to get it so my square root of 3 is in the denominator. Which means y can't be square root of 3 over 2, but
X
x has to be square root of 3 over 2. Alright, so instead of having y be square root of 3 over 2, I'm going to say x has to equal square root of 3 over 2.
Why over 2?
Because if I look at my unit circle, whenever I have square root of 3 in here, it's always over 2.
Doesn't matter if it's negative or positive.
We need one that's going to be positive and one that's going to be negative. We're going to get two different answers. So we're going to let x equal negative square root of 3 over 2 and positive square root of 3 over 2. Right? We're going to get two different answers here. Now, let's say x equals square root of 3 over 2. Alright? So we know y times the reciprocal of that, right? Because we want to keep, change, flip. Y times the reciprocal of, or 2 over square root of 3 is equal negative 1 over square root of 3. So I know that's got to happen. But I need to figure out what would y equal to make that happen. Well, I know for a fact it's got to be a negative number. It's got to be a negative times a positive. But what number that I have in my unit circle here is either x or y, can I put in here for y that's going to make it negative 1 over square root of 3? I'm going to have something that has a 2 in its denominator, right? Negative 1/2. So if I put negative 1/2 in for y, my 2's are going to cancel, and I'm left with negative 1 over square root of 3. Does that make sense? Yes or no?
Yes.
Okay. So in this case, if I let x equal 3 square root of 3 over 2, y has got to equal negative 1/2. Well, if I do it the other way, oops, I wonder- I have negative 2 over square root of 3, because I use x equals negative square root of 3 over 2. What's y going to have to equal?
Half.
Just 1/2, right? Positive 1/2. Because then my 2's will still cancel and I'll get negative 1 on top. And I'll get square root of 3 on the bottom. Does that make sense?
Yes.
Jalen?
Why did we have to do x equals square root of 3 over 2 and x equals negative square root of 3 over 2?
Because I know to get a negative number out here, either x or y could be negative, and the opposite would be positive. Alright? Good question. Any other questions on that? Yes, Kaylee?
If the answer's positive, would you have to do like the double negative side?
So yes, so if it was, this came out to positive 1 over square root of 3, it'd be either both x and y are positive, or both x and y are negative. Alright? Another good question. Alright, I'm not done yet.
Wait.
What I need to do is look at my unit
Just
circle.
from all of them? From
No,
like-
just these two, right? Well, I need to find where, technically yes, all of them. I need to find where this holds true. I need to know where does x equal square root of 3 over 2, and where does y equal negative 1/2. So if I go up here,